The limits of the determinate and indeterminate forms. Before we do this, keep in mind that if we were to take a finite number divided by a very large number, and a very large number is infinity in this case, then we would end up with a very small number, and a very small number is 0, and a very large number is infinity. Similarly, if we take a finite number divided by a very small number, then we would end up with a very large number. The way that we look at this is that if we have a finite number such as 1 million and we divide it by a very large number such as 1 trillion, 1 trillion trillion, then the ratio is very small. Similarly, if we take a finite number such as 5 and we divide it by a very small number such as 0.00000001, then we end up with a very large number indeed. And again, very large number is indicated by the infinity symbol, and very small is 0 in terms of the limit. For part A, the limit at x goes to negative infinity of e to the x. In this case, we take e and we raise to a very large, but it is a negative number because x goes to negative infinity. This is the same thing that we take 1 over e raised to a very large positive number now, because the negative power is the reciprocal. But in the denominator, e raised to a very large number is still very large. And so in this case, we have a finite number 1 over a very large number, which is 0. And so the limit is 0. For part B, at x go to 0 from the right hand side. And so we're approaching 0 from the right. 1 over x squared. Now x go to 0 from the right hand side, then x squared would also go to 0, and it is positive. In terms of the limit, this is not quite equal to 0, but think of it as 0.000001 and so on. But if we take 1 over a very small number, then this will be a very large number. So again, this is 1 over a very small number. Then we end up with a very large number. And a very large number in this case would be infinity. And it will be positive infinity is because x squared is positive, and 1 over a positive very small is infinity. Infinity is not a number. These limits say that the limit does not exist, but it does not exist in a special way. It is increasing without bound. And so for the graph of 1 over x squared, we see that it looks something like this. And so as x approaches 0 from the right, the function increases, go up indefinitely, increases without bound. For part C, the limit at x goes to negative 1 of x squared plus 1 over x plus 1. At x goes to negative 1, x squared would go to positive 1 because negative 1 squared is positive 1. But in the denominator, at x goes to negative 1, then x plus 1 would go to 0. In this case, we would have 2 x squared plus 1 in the numerator over 0, which is undefined or does not exist. But remember that in terms of the limit, this is not quite 0, but it is a number that is very close to 0. It is approaching 0, but not 0 itself. Is it positive or negative? We would have to determine each cases. And so we take the limit at x goes to negative 1 from the left hand side of x squared plus 1 over x plus 1. We see that the numerator is still 2, but the denominator is a positive number, because if we approach -1 from the left hand side, then that number is, think of it as -1.00000001. And if we take -1.0001 plus 1, then it is a very small, but remember that it's very small negative number. And so this is a finite number over a very small is a very big number, and it is negative, because a positive 2 over a negative number is negative. Similarly, we will look at the right hand side limit, the limit at x go to -1 from the right hand side of x squared plus 1 over x plus 1. Similar argument will give a 2 in the numerator, and in the denominator, this time, think of this x approaching -1 from the right hand side as -0.9999999 and so on. And if we take this -0.9999999 and add 1, we end up with a very small, almost 0, but it is positive. And so 2 over a very positive small number is a very big number, but this time it is positive. Since the left hand side limit is -infinity, which does not exist, and the right hand side is positive infinity, they don't go in the same direction. So we conclude that for part C, the limit at x go to -1 of x squared plus 1 over x plus 1 does not exist. If both of these are positive infinity, we would write positive infinity here. If both of these are negative infinity, we would write negative infinity here. But in this case, one on the left hand side, the function is decreases without bound, and on the right hand side, the function increases without bound. The limit does not exist.